Hi, today we're going to learn how to solve multi-step inequalities. We've already solved one-step inequalities and multi-step equations, so today is just a little bit of adjustment. Here are a few things that we need to keep in mind. First, it's only when we multiply or divide both sides by a negative that we switch the direction of the inequality or the direction of the sign. So it's not when there's a negative, it's when we have done something, the same thing to both sides, that is multiplying or dividing by a negative. And we talked about why in our last video. Second, once we are done solving, it is usually best to read the inequality from the variable. That way, it'll read the same no matter which side the variable is on. Third, if the endpoint is included, that means if it's less than or equal to or greater than or equal to, we close in the circle. If not, we leave it open. That's when we're graphing our solution. The solution to an inequality is all the numbers that make the inequality true. That's why we shade or draw an arrow on part of the number line. The shaded part is a picture of all the solutions. That way we don't have to say, oh, it's -2, it's -2.5, it's -3, it's -3.5, it's -3.79. We already have all of the numbers, and there are a lot of them. There's infinitely many. So it's important that we are able to envision what all of the solutions are that make it true. So, good thing, we can solve this just like a multi-step equation. We're going to go ahead and do 3 examples today. If you feel like you get them pretty well, you can fast forward to the parts that you're confused on. Here's the first one. Just like solving an equation, I'm going to draw a line by my inequality symbol. These may be a little harder to find than your equal sign because you're not used to them. Then I have in my fraction, remember that the fraction bar is like a set of parentheses. So I'm going to undo what's outside the parentheses by multiplying by 8 on both sides. Let me change my pen size. And I get -16. And because I multiplied by a positive number, I keep the direction of the sign. And then these cancel, and I get x minus 1. Then I'm going to undo subtraction by adding, and I get -15. And because I added, I still keep the direction of my sign. When you are done solving your equation, you're going to graph it on a number line if there is a number line provided for you, or if the directions say. And remember that one thing I like to put is my 0. I'm going to put my 0 over here since my number is very negative. And I'm going to put my number and the 2 numbers that immediately are adjacent to it. You may have your directions change based on what test you're taking or what you're doing. This is just a quick and easy way to do it. So -15 is my number. I'll circle there. And then I'm going to read this from the variable so that I can know which way to put my arrow. X, and then we have the pointy part towards the x. So x is less than -15. I need the numbers that are less than -15, and less than is always to the left. Because this is not an or equal to, I leave my circle open. And that's how you solve it. Notice on this one, it was exactly the same as solving an equation. That's because we did not multiply or divide by a negative number. Let's go ahead and do another example and see if we might have to switch the direction. I'm going to do E. On this one, just like in solving an equation, if there are parentheses, you should distribute first. So I have -4 minus 20x minus 15. And then I keep my sign because I haven't actually done anything to both sides yet. After distributing, we combine like terms. So I'll have, let's look at my terms here. I have -4, I have -20x, and I have -15. With all these negatives, it can get a little confusing. You can get a little lost. So my greens are -4 and -15. So those together, added together, are negative 19. Okay, now we can do some undoing. So I'm going to go ahead and undo addition and subtraction. This one is subtraction, so I'm going to add 19. And remember that I'm adding, so I can keep my sign. Then I'm going to get rid of this negative 20. It's multiplication, so I'm going to divide. Now, usually what happens to me is I forget, and then at the end I check my answer. But I'm dividing by a negative number here, so I'm going to flip the direction of my sign, and it's going to go the other way. That's negative 6. Okay, I'm going to go ahead and put my answer up here while I graph this. It may be helpful for you at the end to just look through your work and see if you divide or multiply by a negative number anywhere at the end, just to check your sign and be absolutely sure. Let's go ahead and graph this. It is in the negative, so I'll put my 0 over here. Here's my negative 6, negative 5, and negative 7. Now this one's a little smaller, so you could actually fill in your negative 1 through 4 over there, but we're just going to put our circle. And x is less than or equal to negative 6. Less than is to the left, and because it has the equal to bar, I'll fill it in. Okay, I'm going to do one more example for you, and it is example F. This one doesn't have distribution. It does have like terms to combine. So I'm going to go ahead and say negative 1 plus 7 is positive 6. And I didn't do anything to it yet. I just simplified the expression. So I'm going to keep my terms the same. I rearranged these just so it looks a little easier for me. You don't have to do that. Then I can either choose the 2n or the 6n to get rid of. Previously, we've said that we always want to get rid of the one that leaves us with less negatives. And now we kind of have a real reason why. We don't have to remember to switch the sign if we don't have any negatives in the problem. So I'm going to get rid of this 2n over here. And then I get, I was going to think that was negative 4n minus 6. Then I can just do the opposite. And then I get 4n is greater than 12. And then let's undo division. And I get n is greater than 3. That's wonderful. So that was really easy. We didn't have to do anything different than solving equations. I'm going to go ahead and do this problem again, and you can see the difference if I chose to get rid of the 6n. So I'll do it in purple, and I'll do it from this step right here. So if I get rid of the 6n, I'm going to subtract 6n from both sides, and I get negative 4n plus 6 over here is smaller than negative 6. Then I'm going to undo addition with subtraction, and I get negative 4n is less than negative 12. And then I divide by negative 4. And I get n is less than 3. But remember, I divided by a negative. See, I always do this at the end where I have to quick change it. I divided by a negative, so I have to change the direction of my sign. Let's check and see if we got the same answer. When I read this one, it reads n is greater than 3. When I read the other one, it also reads n is greater than 3. So I got the same answer, but when I had no negative, then the problem was a little bit easier. And actually, funny story about me is that when I was in high school, I had forgotten, I wasn't totally positive about this rule about switching the sign. So I just moved around all my terms until I had no more negatives in front of my numbers, and then I just did it that way so I could always get the right answer. So you could avoid this issue by just Like if you had this negative over here and you were unsure, you could just add 4n to both sides and then it's on the other side as a positive and it doesn't matter anymore. But you can also just remember that you changed the direction of the sign. All right, that's it. Good luck today.